Hello, the purpose of this video is to teach you how to go through the steps for completing the square of a quadratic equation. And the purpose for completing the square is to usually to change, that's delta, to change standard form to vertex form. So here's the process for completing the square, the fundamental process. And the first one would be if we had an equation, and let's just go ahead and actually put it in what you might see it as y equals or f of x equals. And so to complete the square, you take half the middle term and square it. So they want to know, like, what is c if you take half the middle term and square it? I go a squared plus 6x plus half of it, so that's 3 squared is plus 9. And what that allows us to do is this is now a perfect square trinomial that can be factored into x plus 3 times x plus 3, which is the same thing as x plus 3 squared, which is why they call it a perfect square trinomial. And that is the basis for completing the square. Now, let's see where things get a little bit dicier. So if we were to look at something like, what would I need for something with a fraction? So how do I take half of 11/8? So if I take half of 11/8, that means I'm multiplying it by 1/2. So 11/8 times 1/2 is 11/16. And then I have to square that. So my C value becomes 121 over 256. And then I know I can factor this to z plus 11/16, z plus 11/16, which then can be rewritten as z plus 11/16 squared. All right. Now, again, using the completing the square technique is the same exact process we just went through. But now, if we want to solve this equation, then the first thing I want to do is make a perfect square trinomial. And so to do that, oops. Okay, so a little interrupted because I had the worksheet in the wrong software, but now we've got it back in the software I can write on. And so again, we want to take and figure out how we can take advantage of completing the square technique to help us solve for a variable. In this case, if we look at number 1, it's p, and we want to take and make part of it into a perfect square trinomial, and that's this part right here. So we know how to do that because we know that if you go ahead and add half of 14 squared, so I would take p squared plus 14p plus half of 14, which is 7, squared is 49. Now, if I add 49 to this side, then I also have to add 49 to the other side so that I keep it balanced. Another thing I could do is I could subtract 49 right afterwards, but you'll decide when to do it at the appropriate time as to whether keep it on the same side and go opposite or go to the other side. Again, I chose to go to the other side. So now, intentionally, I know that this is a perfect square trinomial that can be factored into p plus 7 squared. And if I want to isolate that, now I go ahead and add 38 to both sides, and I get is equal to 87. So now I want to get rid of the squared, so I want to take the square root of both sides of the equation, or raise both sides to the 1/2 power. We'll go with square root right now. So when I take the square root of both sides, I get what's inside as p plus 7 is equal to the square root, plus or minus the square root of 87. And right now, that would be good enough. And then later on, we'll talk about how to simplify and break down 87, if it's possible to break it down into a simpler radical expression. But I still have to isolate p, so I have to subtract 7 from both sides. So I get minus 7 plus or minus radical 87. And so if I plugged in minus 7 plus radical 87 into my original equation, I would get 0. If I plugged in minus 7 minus a radical 87, plugged it in for p, I would also end up with 0, a true equation. Okay. Let's do one more. And one that I want to show you is something that's not so obvious. So let's just say number 16. And this will allow us to highlight a very important point of completing the square. So one of the things for completing the square that you want to do is you want to make sure that before you do it, you have a coefficient of 1 in front of the x squared. So right here, you can see we've got 6, so we've got to get rid of that. And so the obvious thing to do in this particular case is to divide each term by 6. So we end up with x squared minus 8 is equal to a minus 2x. And then our next step would be to get the x's on the same side, x squared plus 2x. And I could leave it as minus x, but I know I'm going to complete the square, so I want to put in a space there. And probably what I want to do is set it equal to x. And then I'll also want to add the same thing to that side. So now I'm going to go ahead and take half of 2 and square it. So that's 1, add that to that side, and add that 1 to that side. And now again, I've got my perfect square trinomial, which I know can now be put as x plus 1 squared is equal to 9. My next step is to take the square root in a different way to annotate than what we did on the previous problem. Is if we raise both sides to the 1/2 power. It's a different way of writing radical that you may not have seen in Algebra 1, but we'll talk about that. So when I raise 2 by the 1/2 power, you multiply your exponents, so that actually becomes x plus 1 to the first power. And that's the same thing as taking the square root of 9, so this becomes plus or minus 3. So then when I isolate x, I get x is equal to negative 1 plus or minus 3, which means that x is equal to minus 1 plus 3, which is equal to 2, or x is equal to minus 1 minus 3, which is minus 4. So it's probably easier to plug these back into this equation here just to make sure that it's true. So what happens when I plug in 2? I get 2 squared plus 2 times 2. 2 squared minus 8. Does that in fact equal a minus 2 times 2? So I end up with 4 minus 8 is equal to negative 4. In fact, that does work. So 2 works. Now let's go ahead and try negative 4. So -4 squared minus 8 is equal to a -2 times 4. Oops, sorry, times a -4. So this becomes 16 minus 8 becomes a negative, and negative is a positive, positive 8. So 8 equals 8. And again, that works out. So both of your answers here for X, which will keep this true, your solution set, or for X, your solution set would be the points 2 and -4. All right, so hopefully you find this useful as to understanding how you do completing the square. And the important thing is, before you complete the square, you've got to get the coefficient in front of X squared equal to 1. All right.